Well, let's start talking about dynamic memory allocation. One thing with dynamic memory allocation is we don't need to know how many variables we need or what size our array needs to be ahead of time. We can allocate that memory while our program is running. And that's pretty nice because what we've done so far, we have to allocate everything before we run the program. And so if we can allocate memory while the program's running, I think you can imagine how useful that's going to be. And so the reason why we covered pointers first is because we can only do dynamic memory allocation with pointers. And what we're going to do is we're going to use this new command to allocate memory. So let me write down the commands you would use to do this, and then we'll just talk through everything. First of all, what we're going to do is declare a pointer. So let's just declare an integer pointer. So int pointer. And I'm going to initialize this to the null pointer just because I think it's good practice to just get used to doing that. And then what we want to do is I'm going to start with just a variable. So we're going to dynamically allocate a variable, and then I'll show you how to do an array after that. So let's say that we want to dynamically allocate an integer. We're just going to say pointer is equal to new int. So what this does is it requests that our program allocate enough memory for an integer. So basically, an integer is 4 bytes. We're saying we want the program to allocate 4 bytes of memory for an integer. And what this is going to do, since it's a pointer, this new command is going to return the address of that memory that we're allocating for this integer. And so now that pointer is basically going to have the value of the memory location of the first byte for that memory. And then if we want to store something in that memory location, we need to dereference the pointer. So we're going to do that with the star pointer. So remember, this will dereference the pointer so then we can store something in the memory location that that pointer is pointing at. So let's just say that we want to store 30 there. So this is us just like in the program, we're just saying, oh, this is equal to 30. But normally if we're dynamically allocating memory, it's because we don't know ahead of time what memory we're going to need. And so this is a value we'll often be getting from the user. So we can do a cin statement. And so let's just take this off for now. So let's say that we've declared a pointer, we've allocated new memory, so we've allocated a memory location that we can store an integer, and now we want to get a value from the user to store in that memory location that we've just allocated. So we're just going to do a cin, and then we need to dereference the pointer. And so that's going to take the value that the user enters and store it into that memory location that we've allocated. So this is for a variable, like one variable. This is most useful for arrays. I mean, there might be times where we might need to allocate memory for variables, but usually this has to do with arrays where we just don't know the size that the array needs to be when we're writing the program. So the way that we can dynamically allocate arrays is we kind of do the same thing. So we want to declare a pointer, set it equal to the null pointer, and then we want to declare, or we want to allocate an array with, let's say we want to allocate a new array with 100 elements, or we want to allocate an array with 100 elements. So this is going to be pointer is equal to new int, and then we're going to say 100. So this is basically doing the same thing that this was doing with the variable, only for the array, so if we allocate this new this array, the pointer is now holding the address of the first element in the array. And then we can use either subscript or pointer notation to access this array. So let's say that, like, let's first use subscript notation. So this is just going to be, and we're going to use a loop to access this because remember we still need to go through the elements, one element at a time. So let's say int I is equal to 0, I less than 100, I plus plus. And then if we want to access this with subscript notation, that's just going to be ptr I, and then let's just say that we're storing, let's just say that we want to store zeros to every element. So let's just say we initialize, or so we declared this new array, and now we want to initialize all of the elements to 0. Well, we figure out what we're going to do with them later. So this is with the subscript notation. We can also access the array with pointer notation. And so with pointer notation, we would just replace this line with this. So ptr plus I is equal to 0. One thing I want to mention is what if we try and allocate new memory and there's not enough? Well, what this is going to do is what's called throwing an exception. And when that happens, basically your program's just going to terminate. So it's going to get an error and it's going to terminate. And this usually isn't a problem if you're declaring new memory for like a variable or say a smaller array. But if you try and declare memory for a really large array, that could turn into a problem. So you just want to be kind of careful about the limitations of your system if you're using dynamic memory allocation with pretty large arrays. So now, if we've allocated new memory, we want the ability to be able to delete that memory once we're done using it, because we don't want the program to hold on to that memory if we're not using it anymore, because if we can somehow delete that memory, it can be reused by the program later. So the way we do that is we just use the delete command. So after you're done using your memory, you would just say delete. In this case, our pointer is just called pointer, so we would just say delete pointer. And this is for a single variable. If we have, let me just write this, so single variable. If we have an array, then this is going to be delete and then ptr. So this is for an array. So it's really good practice to delete. If you dynamically allocate memory, it's really good practice to delete that memory once you're done using it. If that happens near the end of the program, that's okay. It's just good practice to delete it. If you don't, the memory is going to be tied up until the program exits. And the other thing with this delete command is you only want to use it on dynamically allocated memory. If you try to use it on other types of memory, like say a variable that was declared in the program but not as dynamically allocated memory, that can cause unexpected errors. So it can cause logic errors that can be kind of hard to find. So only use the delete on dynamically allocated memory. So you can see how this would be pretty useful if you're working with a system that has really limited memory. Like you could have an array that you're using for one part of your program and then delete that memory and use it for another part and so on. So this is pretty important if you're working with either really large arrays or if you're working with a system that has limited memory. Let's talk a little bit about memory leaks, because this is one thing that can happen if you don't delete your dynamically allocated memory. First of all, you can have a memory leak if you don't delete your dynamically allocated memory. But I'm going to show you a function, and let's just look at what the problem with this could be. Let's say that we have a function that's supposed to be dynamically allocating a new array. Void. So let's say this is a function that's not returning anything. We're also not sending it any parameters. Let's say that inside this function we allocate an array. So constant int size is equal to 100, and then int, and then we're going to dynamically allocate some memory. So int pointer is equal to new int, and size. So this is going to be an array with 100 elements. Just from looking at this, if this is a function, so let's say this function is called from main, so let's say in main we call this function. So once this function ends, this variable that we declared here goes out of scope. This is one thing that can lead to a memory leak. So we can return a pointer from a function. So char, and let's say that this function, let's say that we want to have a function that's going to find the null character in a string or a C string. So I'm going to call this find null, and let's say this is, so we're sending this function a pointer to a C string. And I'm just going to quickly define what a C string is because I don't think we've defined that yet. So we basically have a string of characters. So this could be like A, C, D, and then we have a null character at the end. So let's say that we have a function and we want to find the null character in this C string. So basically we have a string, so well, not really a string, we have a character array, and we want to find the null character at the end of that C string and return it. So what we're going to do in this function is declare a pointer. So char, and I'm just going to say this is equal to string. So we've declared a pointer and set it equal to our parameter that we sent into the function, and then while, and then if we want to, let's say that we want to step through this array. So we want to go through this array until we find the null character. So yeah, we're going to need to dereference the pointer. And then while this is not equal to, and then we're going to give it the null character. So this is going to go through this array until it finds the null character. And each time that we go through the array, we want to increment our pointer by 1. So basically we're incrementing to each successive element in the array. And once we find that, we're going to return pointer. So this is returning the address of whatever spot in this. This is returning the address of whichever element in this array of characters or C string has the null character. A couple things I want to point out with this is that, and this is the issue with this function up here, we don't want to return a pointer to local variables in the string because that's going to, you're not going to have access to those variables once the function is done running. So I'm going to put that the function must not return a pointer to a local variable in the, I'm just going to say in the function. So basically we only want the function to return a pointer to two cases. So to data that was passed to the array as a parameter or argument. So data that was passed to the array as an argument, and to dynamically allocated memory.